Welcome to Learn with Roblox. In today's video, we're going to cover function composition, so let's get in this first problem. This first problem says f of x is equal to x squared plus 3 and g of x is equal to negative 2x plus 1. And based on that, we need to find f of g and g of f. So first thing I'm going to do is I'm going to write f of g and g of f in a different form that you might see in your problems. So f of g, you can also rewrite it like this. Instead of using that open dot between the f and the g, you can use parentheses and do f parentheses g of x, like that. And for the bottom one here, you can write this as g, and then in parentheses, f of x. And this is the form that I prefer because I think it makes more sense, and I'll show you how both of these work. And also another thing I want to get out of the way is that whenever you see this open dot, be careful that you don't confuse it with g dot f in this case, for example. So these dots are not the same. This one indicates multiplication, so it's not the same as this open dot here, which indicates function composition. And I might make a video on multiplication of functions in the future, but let's show you how to do function composition. So I'm first going to do this top one over here, f of g of x. So I'm going to write this form because I think it makes more sense. So we need to find f of g of x. So what I'm going to do first is, we already know what g of x is, right? We can see it at the top. It's negative 2x plus 1. Let me rewrite that. We have f of negative 2x plus 1. And now what is this telling us? How do I do f of minus 2x plus 1? Well, imagine this. What if I gave you like f of 1? How would you solve for that? Well, whenever you see the function x squared plus 3, that's f of x, and you see f of 1, well, we know that just means everywhere you see the letter x, plug in a 1. So to do f of 1, I would just do 1 squared plus 3. So I just plug in the 1. But now likewise, whenever you see x squared plus 3 and you have f of negative 2x plus 1, everywhere where you see the letter x, you just have to plug in everything inside the parentheses. So this whole thing goes inside the letter x. So let's try that out. So now I need to plug negative 2x plus 1 wherever I see an x. So I have negative 2x plus 1 squared plus 3, because I just plug in negative 2x plus 1 wherever an x is in the function f. And now we just need to evaluate this. So let me go down a bit. And now let's just evaluate this. Negative 2x plus 1 squared plus 3. So to do that, I'm just going to first rewrite this as negative 2x plus 1 times negative 2x plus 1. And then plus 3 on the outside. I'm going to erase to make some space for us. And then now let's just multiply this out. So I'm going to multiply negative 2x with negative 2x, negative 2x with 1, 1 with negative 2x, and 1 with 1. So if we do that, we'll get negative 2x times negative 2x is just positive 4x squared. Then if you do negative 2x times 1, that's negative 2x. If you do 1 times negative 2x, that's negative 2x. If you do 1 times 1, that's 1, plus 1. And then don't forget the plus 3. And then if you do 1 plus 3, that's 4. And negative 2x minus 2x is negative 4x. So we have 4x squared minus 4x plus 4. And that is the solution to f of g of x. So I'm just going to erase all this down here and go up. So I can say that all of this, f of g of x, is equal to 4x squared minus 4x plus 4. And we're done with that. So now, let's go on to the next one, g of f of x. So to do g of f, I'm just going to rewrite g of f of x down here. So what is f of x? F of x is x squared plus 3. So let me substitute that in. X squared plus 3. And then now, g of x is just negative 2x plus 1, right? So all this is telling us is wherever you see the letter x, plug in whatever's inside the parentheses. So I'm going to plug in this whole guy into that x. So now let's do that. So now we have minus 2 times x squared plus 3, because we're just substituting the x for whatever's in the parentheses, plus 1. And then now we just need to evaluate this. Well, negative 2x, or negative 2 times x squared plus 3, that just distributes to both of those terms. So we have negative 2x squared, and then minus 2 times plus 3 is minus 6. Then we have the plus 1 at the end. And then minus 6 plus 1 is just minus 5. And that's it. That is g of f of x. So I can rewrite that now up at the top. So now we have this is equal to negative 2x squared minus 5. And just like that, we're done. We have found f of g, and we found g of f. And I want you to notice something. These quantities are not the same. So what you'll find is that f of g and g of f might not be the same, and in most cases, they actually aren't the same. I think it's very rare for them to be the same. So don't expect the same answers for both of them. Let's go tackle a few more problems. In this next problem, we have f of x is equal to negative 2x plus 100, h of x is equal to 27x minus 15, and we need to find h of f of 1. And we need to do this in two methods. So let's try out this first method. Here's what I'm going to do. So to start finding what h of f of 1 is, just start from the inside and work outwards. So start on the inside. The inside says f of 1. How do you find f of 1? Well, that's simple. You just plug in 1 into f of x. So f of 1, it is going to be equal to negative 2 times 1 plus 100. Negative 2 times 1 is negative 2, plus 100 gives you 98. So we've just found that f of 1 is 98. And now we can just substitute that in for f of 1. So if you do that, you'll get h of 98 because f of 1 just turns into 98. And then we just need to find what that is. Well, that's also a very simple task. Just plug in 98 into h of x. So this is just equal to 27 times 98 because we're plugging in 98 for h of x minus 15. And then take out a calculator because I can't do 27 times 98 in my head. But if you do that, I think you get that 27 times 98 is equal to 2,646. Then you have the minus 15. And then 2646 minus 15 is just 2,631. And just like that, we've solved for h of f of 1 by starting with f of 1 and then working our way outwards. So I'm just going to put down 2631 there. And we're done with the first method. Now let me show you one other way that you can solve for this as well. So I'm just going to put a 2 for the second method. So here's how we're going to do the second method. To find h of f of 1, what you can do is find what is h of f of x. So we're going to find this function right now, and then we'll plug in 1 into that function afterwards. So let's do that. So to find the function h of f of x, let's start with f of x. That's just minus 2x plus 100. So plug that in, and we have h of minus 2x plus 100. And then we just need to solve for this now. What is h of minus 2x plus 100? Well, let me just write down h of x. That's 27x minus 15. And all this is saying is, wherever you see the letter x, plug in everything in the parentheses into that x. So I'm going to plug in this minus 2x plus 100 into that x right there. So let me do that. Now we're going to have 27 times minus 2x plus 100 and then minus 15. And then now we just need to evaluate this function. So 27 times minus 2x is just negative 54x. And then 27 times 100 is just 2700. And then we have minus 15. And then do 2700 minus 15. And if you do that, I think that is 2685. So this is our function. H of f of x is equal to minus 54x plus 2,685. Now, all you need to do is, if you want to find h of f of 1, just plug in 1 into this function. So to plug in 1 into this function, just put in a 1 wherever we see an x. That's the only place where x is, right over there. Just plug it in. That's minus 54 times 1 plus 2,685. Minus 54 times 1 is just minus 54. And then just do minus 54 plus 2,685. And if you do that, you should get the same result as 2631. Or the same result as before, which is 2631. So I want you to know that there's multiple ways to evaluate h of f of 1. You can either find f of 1 and then plug that result into h of x, Or you can find the function h of f of x and then plug in 1 into that. Let's go to the next one. In this problem, we need to find z of a of x and then use that to find z of a of 5. So the first thing I'm going to do is let's substitute a of x into z of a of x. So we'll have z, and then a of x is just x plus 1. So let me fill that in here. And then now we need to substitute x plus 1 everywhere where we see an x in the z of x function. So let me just write down z of x again. So z of x is 3x minus 4 over 2x. And then every time we see an x, let's substitute this x plus 1 into there. So I'll put it here. I'll put it over there. So let me just rewrite all of this and find out what it turns into. So we're going to have 3, and then this x becomes x plus 1. And then we have minus 4 divided by, and then 2 times x, but everywhere we see x, we have to put in x plus 1. And then now that's it. That's z of a of x. Let's just clean this up a little bit. So let's distribute that 3. We'll have 3 times x, which is 3x, and then 3 times 1, which is plus 3. And then 2 times x is 2x. 2 times 1 is just 2. So we'll have 2x plus 2 on the bottom. And then 3 minus 4 is just negative 1. And then that's it. That's just z of a of x. So let me just rewrite this here. 3x minus 1 divided by 2x plus 2. We have found z of a of x. And now all we need to do to find z of a of 5 is just plug in 5 for x. So let's do that. We're going to have 3 times 5 minus 1 divided by 2 times 5 plus 2. 3 times 5 is 15, and 2 times 5 is 10. 15, 10. And then 15 minus 1 is 14, and 10 plus 2 is 12. So we have 14 over 12. And that simplifies as 7 over 6, because you can divide 14 by 2 and you can divide 12 by 2. So z of a of 5 in this example is 7 divided by 6, or 7/6. In this problem, we have a of x is equal to the square root of x plus 14, and b of x is equal to x squared minus x plus 2. So we first need to find b of a of x, what that function is, and then we need to use that to evaluate b of a of 2. So let's find b of a of x first. To do that, I'm going to substitute a of x into this expression. And we know a of x is the square root of x plus 14. Now we need to find b of the square root of x plus 14. So first, let me write down b of x. That's x squared minus x plus 2. So if we want to plug in the square root of x plus 14 into b of x, everywhere where I see an x, I'm going to plug this whole thing in. So it'll go into that x squared, and it'll go into that minus x. So now let's do that. So I'm going to write this in parentheses. The square root of x plus 14, that whole thing is squared. Then you have minus x, but x is now the square root of x plus 14. And then we have plus 2. So now let's evaluate this. The square and the square root cancel out, and we're left with just x plus 14. And then we have minus the square root of x plus 14, because I can't really do anything with that. And we have plus 2. And then the 14 and the plus 2 can combine to make 16. So let me just write down what b of a of x ends up being. We're going to have x, and then we're going to have minus the square root of x plus 14. And then I said the 14 and the 2 will make 16 for us. So plus 16 on the outside. Let me step out of the way. And that's it. We have found b of a of x. We found the function. It's this function over here. And then now if we want to find b of a of 2, just plug in 2 wherever we see an x. So we'll insert a 2 in there, and I'll insert a 2 into there, because that's where the x is. So we're going to have 2 minus the square root of 2 plus 14 plus 16. And now we just need to evaluate this. 2 plus 14 is 16. The square root of 16 is 4. So I have 2 minus 4 plus 16. And then order of operations, when you have subtraction and addition, go left to right. So 2 minus 4 is negative 2. And then we have the plus 16 remaining. And then minus 2 plus 16 is just 14. So the answer to b of a of 2 is just 14. And that's it. We're done with this problem. In this problem, we have g of x is equal to pi times x, and h of x is equal to x squared plus sine x. We need to find h of g of x first, and then use that to find h of g of minus 1. So let's first find h of g of x. Let me change the color first. So g of x is pi times x. So I can plug that in for g of x. So all of this will just go into there. So you have pi times x. And then now we need to evaluate h of pi times x. Well, h of x is x squared plus sine x. So what I'm going to do is I'm going to plug in pi times x everywhere I see an x. So I'll put one in right there, and I'll put it in right over here. Now let's just evaluate that. So we have x squared. Well, that'll now become pi times x squared plus, and then sine of x now becomes sine of pi times x. And then to just simplify this, the square distributes to the pi and the x. So we have pi squared times x squared, then plus sine of pi times x. And just like that, we have found h of g of x is this function right over here. So now we need to evaluate it at minus 1. So to do that, wherever you see an x in this function, just plug in minus 1. So we have pi squared times minus 1 squared plus sine of pi times minus 1. So let's evaluate this. Pi times minus 1 is just negative pi. And then minus 1 squared is just 1. And then pi times 1, or pi squared times 1, is just pi squared. Because whenever you multiply something by 1, you get that something again. So you have pi squared. And then sine of minus pi. Now, if you're watching this for Algebra 2, you might not have learned this yet, but whenever you take sine of an integer multiple of pi, such as sine pi, sine 2 pi, sine 3 pi, or sine of negative pi, sine of negative 2 pi, or sine of negative 3 pi, it always becomes 0. So this whole thing is just 0. And then pi squared plus 0, well, obviously, that's just pi squared, because adding 0 doesn't do anything. So h of g of minus 1 is just pi squared. And if you want to put this into a calculator, it is roughly 9.87. And just like that, we are done with this problem. If you enjoyed this video, please consider leaving a like and subscribing. Thank you for watching.